In this example, we're going to be considering a very similar function to the previous example. We've modified the bounds of the for loop a little bit, but that won't affect it too much. So let's get to it. The stuff inside of the for loop is the same as before. It takes constant time. And now we're going to try to understand this by expressing it as a summation. So t of n, the running time as a function of n, is equal to the sum from I equals 1 to radical n in this case. And then we have the sum from j equals 1 to radical n minus I of c. Simplify that inner summation, and we are left with sum from I equals 1 to n of c times radical n minus I. I'm going to continue from here by writing out the terms of that summation to try and understand what's happening. So this equals c times the first value is radical n minus 1. The next value is radical n minus 2. That goes all the way down until we get to radical n minus radical n. To bound this above, we're going to replace term by term with the largest value appearing there, which is radical n minus 1. Or you could make your life easier and replace it with radical n, because that's an even larger value that looks similar and is more convenient. So we're going to bound this above in red, less than or equal to c times radical n plus radical n plus down to radical n. How many copies were there? Well, the first one had radical n copies. I have a typo, I'm going to fix that for you. The first one had radical n copies, so the next one also has radical n copies. So this equals c times radical n. And how many copies of that did we have? Well, we had radical n copies, which gives us c times n, which means that we are in big O of n. So let's write that down somewhere. In big O of n. Now we're going to bound this below. In order to bound this below, we're going to need to split it in half like we did before. So let's do that. We'll do that here in purple. We start with radical n minus 1, then radical n minus 2, then down until radical n minus the top bound, radical n, divided by 2, plus radical n minus radical n over 2 plus 1, plus all the way down until radical n minus radical n. And those last terms I wrote kind of messily because they aren't really going to matter. We're going to throw them away. In this case, our series is decreasing in our index, so the first term is the largest. And when bounding below, we want to keep the larger of the two halves. So we're going to get rid of all of this kind of messy stuff I wrote down here. All that's going away. So greater than or equal to c times radical n minus 1 plus radical n minus 2 plus down till we have radical n minus radical n over 2. That last term can be simplified, and I'll do that in place here. Radical n minus radical n over 2, something times the same something over 2 gives you the something over 2. So this is radical n over 2. Now we replace each term with the smallest term, in this case that's radical n over 2. Radical n over 2 plus all the way down until radical n over 2. And if we're being precise here, how many terms do we have? Well, we have radical n over 2 minus 1 terms because we're starting at subtracting 1 and not at radical n. I'm going to include that for now. But if you forgot the minus 1, it's not really going to affect anything, so maybe we don't care too much. And all of this stuff here tells me that I am in big omega of n. And if we look up, we are also in big O of n, so that's convenient. So t of n, our running time, is in theta of n.